You're welcome to yet another edition of OS e-learning platform. And today we shall move towards generating sample space and a probability. This is for Mathematics 456/1, still under the competence-based curriculum for the new lower secondary curriculum. So I will start with tossing an unbiased coin. Unbiased coin basically means a fair coin that gives an equal 50% chance of a head and 50% chance of a tail to appear. What does it mean? Neither the side is heavier or favored. So it is a fair coin basically if we talk about unbiased. So in this tossing, I will look at tossing a coin, tossing two coins, then tossing a coin respecting the number of times. Then I will look at tossing a coin with a die, and also finally tossing two dice. So we look at sample space. That is where they generate the probabilities depending on the desire of the setter. So the possible outcomes when an unbiased coin is tossed depends on the number of times of tossing and also the number of coins tossed together. So let's look at part A. When one coin is tossed once, so there are only two likelihoods. There is a possibility of having a head on the top or having a tail. So that is why we are saying that it is very, very possible to have what? To have a head or a tail. So this is the sample space, hence giving us a sample number of 2. So each side has a half as a probability to appear. So part B, when a coin is tossed twice, what happens? The sample space is as this. That the first tossing, you are most likely to have a head, and also the second tossing a head. Or it is possible to have a first tossing as a head, and then the second one tail. Or it is very possible to have the first one as a tail, even the second one as a tail. Then lastly, it is very possible to have a tail in the first tossing and a head in the second tossing, using a single coin tossed twice. So this gives us a sample space of four elements and giving the number of sample space of 4. So if I'm to ask anyone to find the likelihood of finding the probability, or finding a probability that the coin, that two heads are shown, so we'll look at only one set, which is head over the total number of 4. Find the probability that at least a head is shown. So you look at a head is here, and also there. So those are 3 a number of events over the 4. So the questions will depend on what the setter wants to investigate from you. 2 coins tossed once. What happens when 2 coins are tossed once? What happens basically? So you realize that the sample space will basically be like the one of 1 coin tossed twice, because the first coin can still show a head, the second one also a head on the first tossing, or in that tossing. There is also a possibility that the first coin showing a head, then the second one tail. But tossing once and together, there's a possibility of having the first one coil showing a head, a tail, and also the other one also showing a tail, and lastly a tail head. So still giving us 4 elements in the sample space of 4 possible outcomes, and this one makes the number of sample space as 4. So in case you are requested to find the likelihood, look at what is the target in the task. Find the likelihood that at least a head is shown. So find the likelihood that at least a tail, at most find the likelihood that 2 heads are shown. So you realize that it is only this that has 2 heads, head, and over the sample space 4. So it will depend on what? It depends on what the scorer wants you to put down. How about tossing a coin and a die once? What happens? Let me assume that it is an unbiased coin, that it has fair chances of each side to appear. And then a die which is numbered basically, or which is dotted with digits from 1 to 6. Basically, those dots represent digits. So if it is one dot, that is 1, 2 dots, 2. Whoever have ever played table dice. So you realize that uh, if it's a fair die, then that should have 6 faces with dots up to 6. So let's look at the sample space. How can I generate a sample space? So the basically the possible outcomes that will make a sample space. So I will look at this as having a coin on one end and then a die on the other end. But still I'm tossing both of them at the same time. So as I toss this coin and die at the same time, the possibilities are here. That is very possible a die to show 1 as well as the head showing, as well as the coin showing a head. And it's also possible that a die shows 1 and a coin shows a tail. A die showing a 2, a coin showing a head. A die showing a 2, a coin showing a tail. A die showing a 3, a coin showing a head. A die showing a 3, a tail being shown on the coin. So these possibilities are very possible and they make up a sample space. What does it mean? If you look at this, you will have 1, 2, 3, 4, 6 times 2, basically 12 number of sample space if you are to count them. So if the question appears, find the likelihood that a tail and an odd number appears. So you look at tails are here. Then odd numbers, you look at odd numbers. Yes, you have 5, you have 3, by definition of odd numbers. So you sample them, you count them out to make a number of events over the number of sample space. Find the likelihood that a head and an even number appears. So you'll still check on the numbers that are even with a head. So that will make up the number of what? Events over number of sample space. So you will see that the sample space helps us to find the likelihood needed. So this is when a coin and a die are tossed once and together. So if you can get a coin and a die, sample this out. We agree these are real life cases. This is not a myth. It is not history. It is not a propaganda. It is reality on the ground. So if you get a coin and a die, toss it. I bet you will get at least, you will get one of these displaying on top. You will get one of these displaying. So what does it mean? I'm not meaning that you will toss 12 times to get this, but all these are possible outcomes. What is very possible to take place, because there is no determinant that it is always 1 and a tail, neither a 3 and a tail, nor a 5 and a what? A head. So since there is no formula for displaying, so we look at all possible outcomes that are likely to occur. So this is something to do with random appearance, random random what? Random tossing. So you can't define a formula for that, that now always it will have a 4 and a tail. So all these are possible outcomes and does not mean you are tossing it 12 times. Okay, lastly, let's look at tossing 2 dice when they are still numbered. Like I said, the dots are numbered from 1 to 6. So the possible sample space will also be generated as follows. So I will take the die 1 numbered from 1 up to 6, and then die 2 numbered from 1 up to 6. Now these are their intersections. The intersection of die 1 and die 2 when 1 and 1 appears on both dice. So these are intersections and they are making me possible outcomes. They're making possible outcomes. So it is very possible that The first die shows a 1 and die 2 shows a 2. Very possible. So all these possibilities make up what we call a sample space. Make up what we call a sample what? A sample space. So what does it mean? We need to exhaust all the possibilities. We need to exhaust all the possible outcomes to make up a sample space that is complete. Like I said, it is not a mandate that all the time you toss it will show a 1. No, so it varies. And since the variation is there, to cater for all possibilities, we need to do what? We need to exhaust all the possible outcomes. So once again, it is possible to show a 2 on the first die and a 1 on the second die. A 3, a 1. All these possibilities are there. So I look at the intersection of the face on the first die and the second die. For example, here you are seeing that die 1 will show a 6, and then die 2 will also show a 6. So for us to exhaust all this, I will look at all the possibilities, like I said, and to know the number of sample space, I will count all this and I will make 6. 6 times 6, that is 36. So this is 6 down 6. So I multiply, I get 36. So this is where now we generate questions or tasks. Perhaps it is a scenario, but realize that the scenario involves tossing 2 dice and basically numbered from 1 to 6. The dots are numbered from 1 up to 6. Now, very many tasks will appear within this. Find the likelihood that the pair, the product of the pair displayed is divisible by 4. Look at such a task. What does it mean? You go to every pair and look at the product. Do you get a digit that is divisible by 4? If yes, you call it a number which is contributing to the total number of events. So you realize 1 times 1 is 1. That is not there. 2 times 1, 3 times 1. 4 times 1 is 4. 4 divided by 4 is 1. So it is divisible. It leaves the remainder 0. 6 times 1, yes, that is 6. But when you get 6 divided by 4, according to our task, 2 times 2 is 4. 4 divided by 4 is divisible. So far we've got two outcomes, 2 possible outcomes. So all this, you exhaust all of them until you get a product of a pair that gives you a number that is divisible by 4. So that is a task. Find the probability that a pair gives a sum that is less than 7. So you go to each pair and sum it up. If it gives you a number that is less than 7, you call it a number that's to contribute to the total number of events. So like 1 plus 5 is 6. 6 is less than what? 7. So that is a number. 1 plus 4. So you exhaust all of them. Find the likelihood that the numbers are the same. A pair gives the digits that are the same. So you'll get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So they are making which number of sample event? 1, 2, 3, 4, 5, 6. Are they 7? No, 6. They are 6. So 6 divided by the total number of sample space, which is 36, gives you what? Gives you the probability. So first and foremost, this table will help us only to get the number of events depending on the task. After that, we dive into finding the probability using the formula number of event over number of sample space. So for now, that is what I actually prepared for you. Tossing a die, tossing a coin, tossing a coin several number depending on the number of times, and also tossing 2 dice at the same time, and lastly tossing a coin and an unbiased die. So all those are possibilities that we shall have in every case, and that is where we shall dive into finding the probability required. Thank you so much. I wish you all the best, and if you found this interesting, please don't end on just enjoying, but also share it with a friend. Let's learn mathematics together. Let's close the education gap in the competency-based curriculum. I wish you all the best. Bye-bye. We meet. So thank you so much for watching. And if you have found this helpful, please share, comment, like, and subscribe to OS e-learning platform. Stay blessed. We meet. Bye-bye.